Good morning, Tamina Khan is here in TKMaths is 1. Today's video is a continuation of complete lessons of M1 A-level mathematics. Now we are on lesson 5, which is on resultant and component of forces. So on this topic we will have 3 videos. The first video, this one has resultant of 2 forces. You can see here parallelogram of forces, resultant of any number of forces, and components or resolving forces. So these 4 aspects we will cover in this video. And for the remaining lessons, you can find the link in the description below. So let's see here. Resultant of 2 forces. What does this mean? When we are talking about the forces which are parallel forces and on the straight line, then it is very easy to find the resultant. Now, for example, if you see in this case, the forces acting are 5 Newton and 3 Newton on this box. Okay, imagine this is some box. And 2 forces are acting on it of 5 Newton and 3 Newton. So total resultant is 8 Newton for these forces, right? Now, if the forces are acting at particular angle, for example, if I'm talking about forces P and Q, which are represented by segment AB and AD, right, here it is, then how will you find the resultant force? There are 2 ways to do that. One is parallelogram of forces. So you can make a parallelogram with the help of these forces. In parallelogram, the opposite lines will have same direction and same force, right? So resultant will be this force. This is called a resultant force. So if question says what is the angle made by resultant force and force P, you will calculate this angle. Some information will be given to you definitely, and we will see those questions. At the same time, instead of parallelogram, if I just take force AB and this force AD, if I join here, right, which is called addition of triangular law. So again it will be the same thing. So this is your resultant force. So both ways you can do it. Let's see the question here now, which will give you more better understanding, I would say. So for example, these are the 2 forces, 4 Newton and 7 Newton, and the angle between them is 25. Imagine this is the object here. So where this object will actually move. Now what the question is saying, find the magnitude of the resultant of the forces and the angle the resultant makes with the larger force. So now you can apply here triangular law, vector addition, or parallelogram law, whatever you like. So in this case, for example, if I'm using triangular law, so this is my vector or force 7 Newton. Okay, head of this I will join with this 4 Newton. Okay, and if I show you with the help of parallelogram, it is the same thing. So resultant force will be this one. Okay, so if this whole angle is 25 degree, right, then what this angle will be? Very good, you can easily find this angle, 180 minus 25. So what it is? 135. Okay, so now this is 7 Newton force and this is 4 Newton force. So how will you find out this resultant force? Which rule you will apply here? Yes, you are right, you will apply here, just 1 minute, 180 minus, it is 155, I made this calculation error. Okay, so now if I apply cosine rule, I can easily find out resultant force. So it is r square is equals to 7 square plus 4 square minus 2 times 7 times 4 times cos of 155, and then I will take square root of it. So let's do it. Pick up the calculator. 7 square plus 4 square minus 2 times 7 times 4 times cos of 155. and then you will take square root of it. It is 115.7532. We write answer in 3 significant figure. So it will be 10.75, which means it is 10.8 Newton. So this is your resultant force, and you have to find out the angle it makes with the larger one. So you have to calculate this angle. So again, it is easy. You can apply sine rule, right? So you can do sine theta over 4 is equals to sine 155 over. Achha, always remember, when you're using this answer into the next part, try not to use the rounded off figure. Try to use the answer or value which is up till 2-3 decimal places to get the more accurate answer, right? So now sine theta, I'm doing calculation here now. 4 times sine 155 divided by so it is 0.15. I'm doing one question very much in detail so that you can understand every step, and then rest of the question I will show you answer also. 9.04 degree. So this is how you have found the angle which is made with the largest force 7 Newton and the resultant force. Now this is the test of your understanding. You can put the video on pause. I have solved this question here, and then you can check your working. So I'm showing you the answer here, but you can put the video on pause. It is always recommended to first of all sketch and then start solving it. You will find it easy to understand also. Exactly the way we have done the previous question. So I have taken similar type of question so that you can check your understanding. Okay, now we have seen resultant, and now we will see resolving forces horizontally, vertically. In M1 it is either horizontally, vertically, or it is parallel and perpendicular to the ramp. So let's see here. For example, this is the force and you have to resolve it horizontally and vertically. Now this is your main force, which is 10 Newton. Okay. So if you want to resolve it, so first of all, this will be the vertical and this direction will be the horizontal. Now let me call it y and let me call it x. So you see sine 60 is equals to y over 10, because SOHCAHTOA, you know, triangle, right angle triangle. So y is equals to 10 sine 60. So this is how you know that your vertical, when you will resolve it vertical direction, it will be 10 sine theta. In this case, theta is 60 degree. And when you are doing horizontally resolving it, it will be what? You will use, absolutely right, cos 60 is equals to x over 10. So every time we will not do it in like this. So you can understand that whenever you have to resolve horizontally and vertically, you take resultant force times sine of 60, and otherwise for x it is resultant force times cos of 60. So this is how you resolve forces horizontally and vertically. So let's do this question. These are 3 questions and we have to resolve or find the components in the direction of x and y. So x is horizontal and y is vertical. So let's do it x-axis. Along x-axis mean horizontally. So if I resolve here, this will be my vertical and this will be my horizontal. So what this will be? Along x-axis, which is horizontal resolving, will be 8 cos 30. You can check the calculator answer. and vertically mean along the y-axis. So it will be 8 sine 30, right? Similarly, in this case, for this force, there is no horizontal. So horizontally or along the x-axis, you can say it is 0 Newton. But along vertically, which is y-axis, it is 10 Newton because it is vertically a vertical direction. So you don't need to apply any SOHCAHTOA here. Always remember, when we're talking about right hand side, it means positive, up is positive. But when it will be downward, it will be negative, left, it will be negative, just like a conventional method. In this case, part C, if you see, if I go here, horizontal resolving it, and then up, vertical resolving it. So horizontal resolving will be what? 10 cos 40. Don't forget to put minus sign along. So this is along horizontally or along x-axis. But when it is vertically, which is along y-axis, it will be 10 sine 40. And you can find answer in 3 significant figure easily. So thank you very much for watching the video. In next video, we will find out these aspects when there are many forces, how to find the resultant of those forces along the